All right, picture this. A critical server's been breached, data's gone, digital alarms are just screaming. So, how do you figure out what really went down? I mean, it's not like you can just dust for fingerprints or check the security cameras, right? Nope. You need a whole different kind of toolkit to follow those digital breadcrumbs. And today, we're going to open that toolkit right up.
So, here's how we're going to break it all down. First up is the evidence capture kit. That's all about grabbing the raw data. Then we'll get into the live system snapshot, which is like what's happening right this second. And finally, we'll open up the advanced analysis arsenal, where we turn all that raw data into actual usable answers.
All right, let's get into our first section. This is really the foundation of any digital investigation, capturing the raw evidence. You can think of this as the digital CSI team arriving on scene. Our job is to bag and tag everything, every digital conversation, every single packet of data, because this raw material, this is where we're going to find the truth.
And the very first tool we're pulling out of the bag is, well, it's a big one. It's Wireshark. If you have ever even dabbled in network analysis, you know this name. It is, for all intents and purposes, our high-powered microscope for looking at every single conversation happening on the network.
So, what does it actually do? Well, the best way to think about Wireshark is like this. It's a security camera that records every single digital conversation. It doesn't just tell you that, hey, two computers talked. Oh no, it lets you replay their entire conversation, packet by painstaking packet, in just incredible detail.
And this is where it gets really cool, because this is how we turn all that raw data into actual evidence. You see a function like follow TCP stream? An investigator uses that to literally read a chat session or see the exact commands an attacker typed. It's like replaying a recording. Then you have export objects. That lets you pull a piece of malware or stolen data right out of the traffic itself. And the display filters? Well, that's how you find the needle in a massive digital haystack, isolating only the attacker's traffic from everything else. Okay, but what happens when you can't run a nice, fancy graphical tool like Wireshark? What if you're on a server and all you've got is a command line? Well, that is exactly where our next tool comes in. Meet TCP dump. It's the lean, mean command line workhorse for capturing data.
Now, this is super important. These two tools are not competitors, they're partners. Think of it this way. TCP dump is the rugged field agent. You put it on a server, and its only job is to capture everything it sees, no questions asked. Wireshark, that's the forensics lab back at your workstation, where you do the deep visual analysis on the evidence that TCP dump collected.
And this right here, this is the classic professional workflow. Step 1, you use TCP dump on the compromised server to silently capture all the traffic into a file. Then you get that file, it's called a PCAP file for packet capture. You get it back to your own machine. And finally, you fire up Wireshark and start the real investigation, picking that file apart piece by piece.
Okay, let's switch gears a bit. So far, everything we've talked about is capturing data to analyze later. But what if you need to know what a machine is doing right now? This next part of the toolkit is all about that. The quick and dirty commands you run for a live snapshot of what's happening on the system.
First up, we have Netstat. Running netstat.ano is kind of like checking a building's current occupant list. It shows you every single active connection, which doors are propped open and listening, and this is the really important part, it tells you exactly which program is responsible for each connection. So if you see some weird program you don't recognize talking to a suspicious address, bam, that's a huge red flag. Okay, next is ARP-A. This one is all about local identity. Think of it like this. Your IP address is like your street address, but your MAC address is like the unique serial number on your device. This command shows you which serial number goes with which street address on your local network. And why does that matter? Because an attacker can lie about this. They can impersonate a trusted device, like your router, and trick you into sending all your traffic through them. This command is how you catch them in that lie. All right, ipconfig/all. This one might seem basic, but it is absolutely essential. This is the machine's digital ID card. It tells you its IP address, its MAC address, and, crucially, the DNS servers it's using to navigate the internet. An investigator needs this baseline information to spot anything out of the ordinary. Like, hey, why is this machine suddenly using a sketchy DNS server in another country? That's a huge clue. And rounding out our live snapshot tools, we have RoutePrint. The best way to think about this is like looking at the computer's GPS or its roadmap. It shows the exact paths your data will take to get where it's going.
An investigator checks this to make sure an attacker hasn't added any malicious detours, trying to secretly reroute your sensitive data through their own servers. Okay, we've captured the raw evidence, we've taken a live snapshot of the system. Now it's time for the final part of our toolkit, the Advanced Analysis Arsenal. This is where we bring out the big guns, the specialized tools that automate the really tedious work and help us make sense of just overwhelming amounts of data. And kicking things off in our advanced section is a tool called Network Miner. So if Wireshark is the microscope, where you have to manually hunt for clues, you can think of Network Miner as your automated forensic assistant. It's the one that does all the heavy lifting for you. It's actually pretty amazing. You just feed it one of those PCAP files, the same kind we made with TCP dump, and it just goes to work. It automatically starts ripping out all the good stuff. Usernames, passwords, images, emails, files that were transferred. You name it. It presents it all in a super clean way. This tool can literally save an investigator hundreds of hours of manual digging. But this brings up a really, really big problem in modern forensics, and that is there is just too much data. I mean, the sheer amount of traffic on a modern network is staggering. Trying to capture every single packet all day, every day, it's just not practical. So what do you do when you can't record everything? And that's where something called NetFlow comes in. And this analogy, it's perfect. Full packet capture, what Wireshark and TCP dump do, is like recording an entire phone call. You hear every word. NetFlow, on the other hand, is like the phone bill. It doesn't tell you what was said, but it tells you who talked to whom, for how long, and when. It's just the metadata. And for spotting big picture patterns, like an attacker slowly stealing gigabytes of data over weeks, this high-level view is way more efficient and just as powerful. Okay, one last cool technique to talk about here is called file carving. The best analogy is this. Imagine someone took a really important document and put it through a paper shredder. File carving is the digital version of painstakingly taping all those tiny strips back together. You use tools like Foremost or Scalpel, and they can dig through raw data to reconstruct files, even if pieces are missing or everything's out of order. So let's do a quick recap of our whole toolkit. We've got our evidence capture duo, Wireshark and TCP dump for grabbing the data. We have our live system triage commands like netstat, ARP, and ipconfig for that what's happening now snapshot. And finally, we have our advanced analysis arsenal with tools like Network Miner and NetFlow analyzers to tackle the big jobs. And all of this brings us to a really big final question. Think about it. Networks are getting faster and faster. And, more importantly, almost everything is becoming encrypted. A lot of the deep inspection we just talked about, it's getting harder, sometimes even impossible. So it really makes you wonder, right? Which of these tools are going to become obsolete? And what's going to replace them? What will the next generation of digital investigators need to keep finding the truth?